Hello there and welcome to the Evergreen Building, College of Southern Idaho in Twin Falls, Idaho. I'm Professor Shawn Willsey, and this is another episode of Rock Identification with Willsey. Today we're going to focus on, we're still in the sedimentary rock group, and today what we're going to do is focus on the carbonate rocks, both limestone and dolostone, look at some of the varieties, talk about where these rocks form. And then ultimately, just like all of our rock identification series, our goal here is to help you with your rock identification skills when you're out on hikes and adventures or looking at rocks in your own collection, maybe helping a friend with their rocks. So let's go ahead and get to it here. And we'll start, as we often do, with some information and some notes here. So let me get the tripod set up and we'll run through some fun information about these rock types. So today, again, we're focusing on the sedimentary rocks, and we're focusing specifically on limestones and dolostones, what we sometimes call carbonate rocks, because these are rocks that contain carbonate, CO3, along with a few other chemical ingredients. And so let's see. So let's focus, on limestone first. So limestone is calcium carbonate. So it's this combination of elements here that makes it somewhat unique. And to be a limestone, we need to have a rock that is totally made out of calcite. So it pretty much needs to be, maybe not 100%, that might be overstating it a bit, but 90+% of the rock itself should be made out of the mineral calcite. If you remember back to our mineral series, one of the ways we can distinguish calcite from other minerals that might look somewhat similar is with a small amount or a drop of dilute, 10% in this case, hydrochloric acid. You might be able to get this commercially, I'm not sure. Of course, I work here at a college, so we have a chemistry department, and they're able to put together a simple bottle of that solution for me. But you could also, I think, use vinegar. You might try, if you have a local college, university, or a chemical supply company, if you take them in a little dropper bottle and ask them to make a 10% solution for you, they might do it. I don't know. You'll have to check around and see what options are available there for you. But limestone is actually one of our most common rocks that is not made out of a silicate minerals. So silicate minerals would be things like quartz. We went through a lot of different silicate minerals as we talked about igneous rocks, because those are predominantly made out of silicate mineral material. So this one's a little bit different because it does not contain silicate minerals at all. It's dominantly these carbonate minerals like calcite. The color of limestone can vary quite a bit. Sometimes it's somewhat gray. Sometimes it can be tan, black, white, yellow. I think gray is probably the most common color. In fact, as I look at some of the samples I have here to show you, they're mostly gray. I guess I got a couple here that are more brown or tan, but realize that there's some variability in color. The grain size of limestones can vary from large fragments or kind of a coarse grained material to very fine grained. One of the cool things about limestone rich environments is that because calcite is somewhat soluble, so if we put that drop of hydrochloric acid on it, it dissolves. So when we have areas where limestone rocks dominate and we have rain falling from the sky, that rain tends to be a little bit acidic. I'm not even talking about acid rain, just normal rain that falls through the atmosphere, picks up a little bit of CO2 in the atmosphere. As it moves down through soil, it can pick up a little bit more material to make it a little bit acidic. And so the point here is when groundwater or surface water, especially from rain, encounters limestone, it actually over time will dissolve that rock. And in some situations, it's going to create caves in the subsurface below the water table. It might create these things called karst landscapes, which is a very evolved, mature area underlain by limestone where groundwater has dissolved out lots of caves. You might have disappearing streams and sinkholes, that sort of type of topography. Limestone's an interesting rock because out here where I live in the desert in the American West, limestone forms big cliffs. It's a very resistant rock type. It's one of the main, in fact, the biggest cliff in the Grand Canyon is the Redwall limestone. A Mississippian age limestone forms the tallest, most formidable cliff band in the Grand Canyon. But you take this same rock and you get it in a kind of more temperate or even humid climate where there's a lot more rainfall, and it weathers quite quickly because of the soluble nature of the calcite. And so it tends to not form outcrops or cliffs, and it tends to form more subdued kind of landscapes in those types of climates. So, okay, a couple more things about limestone, and then we'll look at some actual rocks here. So the main ways that we get limestone forming is accumulation of organic material. So there's all sorts of little micro and macroscopic organisms in the ocean who precipitate a shell or hard material that's made out of calcite. And so as these small organisms live and then die, their shells, their exoskeletons tend to accumulate on the seafloor in various environments, and that material can then get compacted and cemented together to form limestone. So that's probably the dominant way we get limestone forming in many environments. The other type of environment we might see limestone forming is if we have calcite that's already there, that maybe gets dissolved with water, and then later in some favorable situation, it gets precipitated out of solution. So in other words, it actually goes from being dissolved with the liquid to actually forming a solid residue at the surface. And we see this dominantly maybe in caves. So if you've ever seen like a stalactite or stalagmite in a cave, some of the cool cave features, those are technically small limestone deposits of calcite. You might see it around springs, maybe like Mammoth Hot Springs in Yellowstone, where we have these extensive travertine terraces. Travertine is a type of limestone we'll look at. So those are probably the dominant two ways. You can also get limestone forming in, as we see here looking at depositional environments, you can also get it forming in lakes as well. So it's not always marine, it can be on land as well, so in a freshwater environment. But dominantly, most limestones out there that you might encounter, the first thing you should think of is a marine environment, maybe a reef or the shallow water that's just offshore, what we sometimes call the continental shelf. And then limestone has all sorts of uses, but its major use is in making cement. So a couple different types of limestone, and then I'll show you some rocks I've got picked out here. So just identifying a rock as a limestone is great, and you can definitely stop right there. But if you want to try to go a little bit more specific, and this is a pretty simplistic set of types of limestone, there's actually a little bit more complicated forms of looking at limestones with wax stones and bound stones, and you can kind of deep dive into carbonate petrology if you choose to. But keeping this something that's fairly user-friendly, a lot of limestones tend to be gray and kind of fine-grained. That'd be what we call a micrite or a micrite. An abundance of fossils in a limestone might necessitate the use of this adjective before the word, so we might call that a fossiliferous or a fossil-rich limestone. How many fossils is abundant enough? Kind of up to you, but if you have just one shell in your limestone, I definitely probably wouldn't call it fossiliferous. I'll show you some examples here where you just see a diversity and a very abundant amount of fossils within some of these samples. If we have a limestone that's pretty much composed of shells and shell fragments, this is what's called a coquina. So these are oftentimes found closer to beaches and closer to the shoreline, where the wave action and the energy of the ocean breaks up the shells and some of the organic material and exoskeletons, and then they accumulate and get deposited, and then they get glued together, usually with the same calcite cement. We'll look at a couple examples of that. Chalk, which you probably heard of, but chalk, unlike the everyday use of chalk where you just write on your sidewalk or something like that, chalk in geology terms is a specific rock type. It's specific to a type of limestone. It's usually white, powdery, fine-grained. One of the more famous examples of chalk is the White Cliffs of Dover in southern England, a great example of chalk forming an impressive landscape. And then the last one we'll look at, and we'll kind of put these together because they're quite similar, travertine and tufa. You probably heard of travertine. It's used for countertops and as a decorative building material. Usually this forms at springs or any sort of water environment in which we have the calcite dissolved in the water. So there's quite a bit of dissolved calcite in the water in maybe a lake or a stream or something like that. If the rock material that forms the limestone is highly porous. That's sometimes called a tufa. And that's to make sure we differentiate that from tuff, T-U-F-F, which we learned is a volcanic rock made completely out of ash. So a couple types of limestone there. Let's go ahead and bring the camera over here and look at a few types of limestone here. Let's start with this micrite here. And so you can see pretty fine-grained overall, kind of a lighter color to it. It's actually kind of smooth to the touch. Could be mistaken without proper analysis. I could see how someone might, with this kind of smooth, seemingly hard surface here, might mistake this for chert or maybe some other rock. And we'll get to chert in our next video series. But remember, the telltale sign of all these limestones, of course, is the acid test. So if we put a drop of acid on it and we get that strong reaction there where the chemical reaction taking place where we're releasing the CO2, that's a good indicator that we've got a rock totally made out of calcite, and in that case we have some sort of limestone. I won't put a drop of acid on all of these, trust me, they fizz, but there's a nice example of a micrite. You can see the very kind of fine-grained nature on the interior of that rock. This is maybe another one here, a little bit more gray in color. This one's actually kind of neat because we have some of these little pits on the surface, which I would interpret as just little places where the rain, perhaps in a desert environment, has dissolved out a little bit of the rock itself. So these little kind of dissolution pits on the surface here. And again, darker color, but still strong reaction with the acid to let us know that it's a type of limestone. And again, this one's kind of a fine-grained material, so this is a good example of a micrite as well, I would say. Looking at some fossiliferous limestones, we'll start with this one. You can see just all sorts of material in here. We've got a brachiopod over here, some crinoids, these little kind of disc things, little donut-shaped things. These are invertebrates. These are part of the echinoderm phyla. What else is in here? Look at it. Here's a crinoid stem right here, so a whole section of them. Here's a gastropod, a snail, kind of just coiled up there. Another brachiopod here. But the point is, you can see that there's just an abundance on this bed of fossil material. And so this is what we would call a fossiliferous limestone. This was actually collected. This is not mine. This is one that was already in the collection from near the Ohio-Indiana state line, along I-74 on the north side near Waynesville, Indiana. So there you go. So some great fossiliferous limestones that are found often back east. Here's another one. This one I did collect. This one is from, zoom out a little bit. This is from northern Nevada, of all places. This is, I believe, Permian in age. And this one you can see some of these really big, again, kind of discs or washer or donut shaped features. These are crinoids. So again, we have lots of crinoid shells in here, and just the sheer abundance of these in this rock would be enough, I would say, to call this a nice solid fossiliferous limestone. Just chucky jam full of all sorts of good critters there, good marine invertebrates. So another fossiliferous limestone. Let's see, one or two more, at least of this type. This one, maybe you could call this a fossiliferous limestone. These are actually horn corals. I might do a video, if it's helpful, I could do a video on some of the common invertebrates that you often find in sedimentary rocks, different types of coral, other invertebrates, brachiopods, pelecypods, clams, snails, that sort of thing. But this one, even if you get in here and zoom in closely, you can see a lot of these small little shapes in here are actually just broken up fragments of marine exoskeleton. So this one could also be considered a fossiliferous limestone, just given how many fossils we see in it. And then one last one here, just one, it's got some coral in it. This is actually colonial coral, or what's sometimes called chain coral. You can see the coral coming through here, and then in the top view, all the little circles there. So it's helpful if you learn a little bit about invertebrates. A lot of times you can identify a lot of the fossils in some of these these limestones. Let's look now at a coquina. So a coquina has, usually they're kind of white, they're kind of porous. They'll definitely elicit a really strong reaction with the acid, but then it kind of fades away because it's so porous that liquid just kind of disappears inside of it. But as you look at the side of this, you can see just all the shell material that forms the rock itself. You can see kind of a bigger piece of a shell there, but just broken shells more or less glued together. That's a coquina. Chalk is a rock probably that you would identify pretty easily on your own. You can see it's pretty powdery. It's white in color. It's quite porous, so we hit it with the acid, it goes crazy, but then it quickly seeps down into the rock itself. So chalk, another type of limestone. Then we have, clean my hands real quick in the area. Maybe we'll just slide this over here. We'll look at a couple types of travertine. Or let's start with the travertine, and we'll do the tufa. So these are different types of travertine. Travertine, many times it's often banded. So you can see there's some banding in this as well. The colors can vary quite a bit in travertine because of impurities. And because of the banding and the impurities, you can kind of see why this might be a desired rock to be used for decorative purposes, for different types of building stones. Here's another one here. You can see some of the layers in it. Sure enough, it will fizz as well, so it dissolves with the acid. But yeah, a couple just nice samples of travertine. And then in a similar fashion, we have tufa. And this one's kind of interesting here. You can see the crazy tube shapes in this. This was actually collected near lava hot springs in Idaho. And the mountains there are surrounded by limestone. So when it rains, you get a lot of calcite dissolved in the water. And there's a stream, or the Portneuf River that runs through there in places is very concentrated in the amount of calcite that the stream has. And so on the banks of the stream where you have reeds and grasses that are growing, it'll oftentimes precipitate a coating of this tufa or this limestone or this calcite around some of the reeds and plants over time. Of course, the organic part, the reeds themselves, they tend to dissolve away, and you're left with this hard mineral material here. Here's another one that's I think from the same area, but you can see some of the holes running through it. That was where a stick or a twig or a piece of grass or some sort of vegetation was sitting in there. But these are all called tufa. Again, strong reaction with the acid, letting us know that there's calcite there. And then finally, our last rock we're going to look at real quick, so we'll come back to the notes briefly. But a close relative, I suppose, of limestone, another carbonate rock, is a rock called Dolostone. And Dolostone is basically, has the same ingredients, but instead of just being calcium carbonate, some magnesium has replaced some of the calcium, and so it's a calcium magnesium carbonate. You'll often see this referred to sometimes as dolomite. I prefer Dolostone because dolomite, remember, is a mineral. And so when someone says dolomite, it can be confusing as if they're referring to the mineral or the rock. So I prefer Dolostone. But in some instances, you might see sedimentary rock referred to as dolomite, just depending on maybe location. I think regionally there's some bias there, and then maybe how old the publication or the references that you're looking at. So it can look really closely, very similar to limestone, but it's much less common. So chances are, if you're looking at something you suspect to be a carbonate rock, more likely to be a limestone than a dolostone. And really the only way in the field, a simple way to tell the difference between dolostone and limestone, because dolostone is made out of the mineral dolomite, and of course limestone is made out of the mineral calcite. And one way we can distinguish those two is calcite always has that really strong reaction to the acid, whereas with a dolostone, you might not get much of a reaction. It might be bubbling kind of slowly, or sometimes what you need to do is actually kind of scratch the rock and powder it a bit, and then you can get a little bit better reaction. But you'll definitely see a difference in terms of how well the rock reacts to the acid, in terms of how vigorous the bubbling and the fizzing is. So sometimes we call the process of changing a rock into dolomite dolomitization. So dolostones, we think, mostly form originally as a limestone. So some limestones actually have fluids maybe moving through the rock after they're deposited, replacing some of the calcium with magnesium, and that's what makes a dolostone over time. The process isn't 100% agreed upon or deduced. And then there's this kind of interesting situation where we see most dolostones in the rock record seem to have a pretty good correlation with time periods in which sea level was quite high. And so there's definitely some people looking at that to figure out, like, well, what's going on there? Why are dolostones preferentially being formed at times of high sea level stands? So the two dolostones I have for you, got one here and one here, one kind of gray, one a little bit more brown. Again, they'll look a lot like a limestone. They might have fossils in them. These two, as far as I can tell, do not, at least anything that's readily obvious. But they may. So the dolomitization process will oftentimes preserve fossils. So if you see fossils in the rock, it doesn't necessarily let you know if it's a limestone or a dolostone. So again, if you put the acid on something like this, you might not get much, but perhaps you test it, you think it's soft, it's not a sandstone, it seems to maybe, you think it may be a carbonate rock. So another way to kind of test it is to scratch it a bit with a glass plate and then put it on there. And if I zoom in, hopefully you can see that it's bubbling there a bit, it's fizzing. So we'll do that with the other one real quick, just for fun. People always love this. Just putting the acid on the rock and seeing the little show, if you will. So yeah, this one's not so much maybe. There we go. We're seeing a little bit of bubbling there. There's some reaction going on right here, kind of small but subtle. Maybe we'll try this side too. I did it earlier and got a pretty good reaction. So hopefully I grabbed a good sample. The other one's definitely a dolostone. This one I was assuming was. Maybe not though. All right, well, 50% on this perhaps. So I'll have to look at this one again with some more details. So anyway, well, hopefully that was helpful. Reviewing a few of the carbonate rocks, the limestones and the dolostones. I think we'll do one more video for sedimentary rocks. We'll include chert. We'll look at types of coal. We might do something with a rock called diatomite. What else? I'll see what I come up with, but we've covered all the clastic sedimentary rocks, sandstone, conglomerate, that sort of thing. We'll finish out with the biochemical sedimentary rocks. And then I suppose the next few videos to look forward to is we'll spend a few videos looking at the metamorphic rocks. And then I think we've got it covered. We've covered most of the rocks and hopefully helped empower you with some knowledge and some skills on some information that'll help you as you get out and try to identify rocks in your area and in your landscape. So appreciate you joining me, appreciate your time, appreciate any support you can send to support these videos. There's donate button on the banner of the YouTube page. There's also a donate link or other options for donations under the video description for all these videos. So appreciate your time and have a great day, and we'll see you next time with rock identification with Willsey.